Okay, part 4 or 5, I can't really remember. We are up to working out the strength of our beam, the bending capacity. We've already worked out phi, K1, 4, 5, sorry, 6, 9. We've just worked out K12. So the next thing to do is F-B, which is the strength of our beam in bending. To do that, we have to go to Appendix H. Appendix H.2, and book opens there naturally. And FB is the characteristic value in bending for an F11 beam is 31 MPa. So FB equals 31 MPa, and that comes from table H2.1. And the last thing we need is our Z value, which is BD squared over 6. You may recall that the Z value is derived from the I value, and it's actually the I over the Y. So we had the BH cubed over 12, divide by that by Y, that's a D over 2, that's how you get the BD squared on 6. So that's called the section modulus, and that's in cubic millimeters. And so that is, B is 45 millimeters, D is 240 squared over 6 equals 45 times 240 divided by 6 is 432,000 square millimeters. Alright, so now let's go and put it all together. So MD equals our phi value, which is 0.9 times, I have to go through our pages here. Our phi value is 0.9, our K1 value is 0.94 for snow, our K4 was 1, our K6 is 1, our K9 was 1, our K12 is 0.867, our FB value is 31, and our Z is 432,000 cubic millimeters. And this, of course, is going to get us a value in Newton millimeters, so which will translate up. We go 0.9, 0.94, 111, 0.867, 31, 432,000. Multiply all that out, I get 982,790 Newton millimeters, and that's a moment capacity. So to get Newton millimeters into kilonewton meters, we're to divide that by a million. So we're going to end up with 9.822 kilonewton meters. All right, that is our MD. That is the capacity of our beam, and we know that our M star, which was the load, from page 1 was 10.02 kilonewton meters. So this is where we play the very sad music, because we've just discovered that our beam fails by like 2%. It's not much, but it's enough to go one size up. And look, the honest answer is that's probably a reflection of the fact that, you know, where I said the span depth ratio was right at the upper limit. Maybe we shouldn't have pushed it to the upper limit. So if I was doing this, you've got a couple of choices. You could pull the beams together slightly, so from 900 to say 750 mil, that would do it. You could use a slightly wider beam, that would do it. Or of course you could go a deeper beam. Be aware that when you go deeper beam, your K12 value changes. So you've got to factor that in, but it would more than make up for it. So you're going to need a beam slightly bigger than 240 by 45 millimeter will not work. The other thing, of course, you can do is change to like an F18 or an F22. You increase the strength, you're going to more than make up for this 2%. So because it's very close, there's quite a few options ahead of you that you can do. So that is how you do the capacity of the beam in bending.